So when we have a really big thing like this, it has multiple functions. For example, if we're going to plug in x, we start with here, right? So we plug in x, and then we perform this first function. This is one function. We x squared plus 8x. Then we take the square root. That's our second function. Then we get a something. Then from that something, we do a third function. We put it into our sine function. So this is our third function. Then we get something else out, and we put that something else into our tan function. Fourth one, right? And then, after we got all of that, we raise it to the fifth power, which is our fifth function. So basically, we're going to see how we can use the chain rule of multiple functions. It can get a little confusing, but it's literally the exact same thing as if you had only one or two functions. Yeah. So let's see. Two functions. You can with one function it won't do anything. But let's see how we can do this. So chain rule. What we do, we take the derivative of just the outside function being the most, like the last function. So if we plug in x, what's the last thing that we do? We put it to the fifth power. So that's like our outside. Okay, so this is our fifth function, and we're going to start with the outside one. So what we are going to do is we are going to set this derivative equal to, we're going to basically take the derivative of the outside one, so we use the power rule, and when we write it down, it's going to look like this. Bracket tan of sine, so I'm just rewriting the inside exactly how it is, and then I'm going to move this to 1 degree less, making it a 4, and that's just the power rule. Okay, so I'm just going to write all of that stuff down, 8x, right, and then double parentheses, and raised to the, one more thing, when we have a square root, what we are going to want to do is that we are going to put it to the 1/2 power. So we're going to write it just like this, x squared plus 8x raised to the 1/2 power. Okay, and then we just put our brackets and make that a 4th degree. And what is this going to be multiplied by? So this is our outside. Well, this is our inside. It stood the same, right? It stood the exact same, but we just changed this outer piece. So now we have to write the derivative of this guy. So right. So that's basically the answer to our problem. Derivative of. Okay. So it looks like we're running out of space. So I'm gonna write it down here. Basically, it's this times tan sine x squared plus 8x raised to the 1/2 power, and yep. So and we're gonna multiply that by we're gonna multiply this guy by the derivative of the inside function. So you see, basically, our inside function is this guy, and we're just gonna take the derivative of it. And that's basically our answer. So our answer is the derivative of this crazy guy is the derivative of the outside function, keeping the inside the same, times the derivative of just the inside function. But, if they're asking us for the derivative, we cannot give them an answer with the derivative in it, right? So what we're actually going to do is we're going to keep on solving the derivative each time. So what is the derivative of this guy? So derivative, so let's just make a squiggly line. Okay, so we're going to take the derivative of this guy. So derivative of tan, and this time we got rid of our we got rid of our fifth exponent. Okay, so let's see what we're going to do here. So sine x squared, well, it's double parentheses because it's x squared plus 8x to the 1/2 power, and then double parentheses, and then bracket. Okay, so now we have to take the derivative of this. So the derivative is that we're going to take the outermost function. What is the outermost function? It's the tan, right? You plug in x, that's the first function, second function, third function, and our last function is tan. So what is the derivative of tan? Derivative of tan is just secant squared, and then we keep everything else the same. In this case, this is what we keep saying. It's the inside function. So now we're just going to plug in everything from there. Sine, and then double parentheses, x squared plus 8x raised to the 1/2 power, and yeah, that's pretty much it. Times what? Times the derivative of, and we don't need the parentheses anymore, and the brackets I mean. Okay, and times the derivative of the inside function. Okay, and let's just write that dude. Okay, sine of x squared plus 8x raised to the 1/2 power. Just like that. Okay, now we're going to want to find this derivative. So let's make a squiggly line. The derivative of this guy. Again, we can write our answer as this times this, because this is the same thing, times this. But we don't want to give an answer in the derivative, so let's solve this guy. So we're going to say, what is the derivative of sine of double parentheses x squared plus 8x raised to the 1/2? Okay, so what's the derivative of this? So remember, derivative is what's the derivative of sine? It's cosine. And then, we're gonna keep the inside the same. So when we do that, we get x squared plus 8x raised to the 1/2 power. And then we're just gonna look at our inside function, this dude, and we're just gonna write the derivative of it. We're applying the chain rule again and again and again and again. Okay, so let's do it. Let's plug in this guy. So it's x squared plus 8x raised to the 1/2 power. Squiggly line. Okay, derivative of this dude. Okay, so let's write it out. X squared plus 8x raised to the 1/2. What's the outside function? Outside function is this dude. So we're just, because look, you plug in x, this is our first function. Second function is this, okay? Write it out. Second function is raising it to the 1/2 power. Okay, so erase all this notes. Okay, and now when we take the derivative of this outside function, what do we get? We apply the power rule, and we get a 1/2 on the outside. We get x squared plus 8x. And then we subtract 1 from the degree, which is negative 1/2. Now we look at what is our inside function. Inside function is just this guy. So we're going to write times the derivative of x squared plus 8x. And, well, we don't need to write this out again, because what is the derivative of x squared plus 8x? Well, let's think. We'll apply the power rule. It's just going to be 2x, right? And then plus 8. So instead of writing a new line for here, we already know what this is. We can do it mentally, and we can say that it's, well, not mentally, but we can just write it out. And we're just going to say it's just times 2x plus 8. Okay, what the heck is our answer? Let's see. Our answer is going to be anything that's like a number and not a derivative. Okay, so the derivative of crazy guy is this times, well, we can't include that in our answer, right? We said this was literally equal to this, okay? Okay, and then we said that this was equal to this times this, right? So, but we cannot write this one in our answer. So this guy is going to be equal to this times this, okay? We cannot include that in our answer. So this guy is equal to this times this. And both of these we can include in our answer. So our answer is actually going to look like this times this times this times this times this. And then simplification. And that's how we do it.